Okay, so let's work with question 2 with oligopoly. So we have two firms competing in the market by setting quantities simultaneously. So this is a Cournot oligopoly. We have each of their cost functions just linear, which is convenient, and they look identical. So we have x1 and x2 for each firm. So we have our inverse demand equation, and quantity is just the sum of the two individual firms' quantities. Okay, so what we're doing first is to find the best response functions for firm 1 and firm 2. And then we'll go ahead and graph these. So the way we do this is we take the demand, the first thing we do anyway is take the demand equations. So we have price is equal to A minus Q, and then we'll just plug in Q1 minus Q2. Okay. So the next thing to do is to find where MR is equal to MC. So to do this, we need to find both MR and MC. So MC is just 1, and MR is the derivative with respect to Q. Let's do this with respect to 1. Q1 times price, which we get from the demand curve. So A minus Q1 minus Q2 times quantity, which is Q1. All right. So we just evaluate this derivative, which gives us A minus 2Q1 minus Q2. And we'll set this equal to MC, which is equal to 1. So we have A minus 2Q1 minus Q2. And then we solve for Q1. So that gives us A minus Q2 minus 1 is equal to 2Q1. Then we divide both sides by 2. So we get Q1 is equal to the best response BR1, which is 1/2 A minus Q2 minus 1. Okay, so that's our best response for 1. And then because these are symmetric, we have Q2 is equal to BR2, 1/2 A minus Q2, Q1 minus 1. So these are our two best response functions. And then the last part of this question is to graph this. So we're going to graph the best response functions. And let's see. So I've sort of run out of space. I'm going to just rearrange a few things. And let's bring this guy down here. Maybe let's just delete this. Okay. So our graph, when we're dealing with best response functions, we want one quantity in one axis. Let's do quantity 1 and the other on the other. So for the first, so best response function for 1, when Q2 is 0, best response function is equal to 1/2 A minus 1. And as we increase, we look something like this. We can find this intercept here by setting quantity 1 equal to 0. So when we do that, we have 1/2 gives us A minus Q2 minus 1 is equal to 0. So then Q2 is equal to A minus 1. So this is A minus 1. Okay, so this is the best response function for 1. Now for Q2, it's going to be symmetric. That's not symmetric. So here we have 1/2 A minus 1 and A minus 1. Okay, so then our intersection is the Nash. So that's what we're going to do in the next question. So for part B, we find the Nash equilibrium price, the quantity produced by each firm, and the profit for each firm. Okay. So the first thing to do, the easiest way to solve this is to find the quantities first. So we have Q1, which is equal to 1/2 times A minus 1 minus Q2. So here we're going to plug in for Q2. 1/2 A minus Q1 minus 1. And from here, we'll just simplify. We have 1/2 A minus 1 minus 1/2 times 1/2 A minus 1. So we're just picking up this and this, which leaves us with negative. So just looking at this Q1. 1/2 times 1/2 times Q1. Okay. So from here, we'll combine terms. So we have 1 times Q1 minus 1/4 times Q1. And that's equal to 1/2 minus 1/4 times A minus 1. And from here, we'll just simplify these parentheses, which gives us 3/4 Q1 equals 1/4 A minus 1. So then Q1 is equal to 1/3 A minus 1. And that's the solution for the equilibrium quantity produced by firm 1. And because it's symmetric, we can show this is the same for firm 2. Okay. So the price We get it from the demand curve. So it's A minus Q, which is Q1 plus Q2. Q here is Q1 plus Q2, which is 2 over 3, A minus 1. So 2 over 3, A minus 1. And we can simplify this just a little bit here. We have 1 minus 2 over 3, A, plus 2 over 3. So our price is equal to 1/3 A. Nope. 2 over 3 minus. No, I was right. It's 3. This is 3 over 3. Just getting my fractions confused. 1/3 A plus 2/3, and that's our price. Okay. Let's move this up here. Maybe slide this down. Okay, so then our profit is so we've sort of run out of space. Maybe we'll do it on the side here. Let's see, can we shrink this? Nope. Okay, so let's just do this on the side. So our profit is equal to average cost times price minus, price minus average cost times quantity. So average cost, we need to take our quantity and plug it into our cost equations up here. So average cost is C over Q, which just comes out to be 1. So that's convenient. We know what our quantity is because we already defined it here. So all we have to do is plug in our numbers. So we have quantity of 2 over 3 A minus 1 times 1 over 3 A plus 2 over 3 minus 1. And I apologize for my large writing. This simplifies. We're going to simplify it with maybe just one more step here, and then we'll leave it as is. Actually, I'm just going to leave this as is. We have the form, and I don't want to make it too much more complicated. Okay, so the last part here is, let's say we have 3 firms instead of 2, each with the same cost equation. So the idea here is to find the Nash equilibrium. So the same idea applies. We've done all this math above. The only difference is that we have a Q3 and gives us a Q3 here. So that's the only difference in the problems here. So let's just write down. We'll use this solution for plus RQ3 with to give us the solution here in part C. So we have Q1, our best response for 1 is equal to 1/2 A minus Q2 minus Q3. And that's true for each of the three. So the classic trick here is that because these are symmetric, so by symmetry, Q1 is equal to Q2 is equal to Q3. So we're just going to call this Q. Okay. So the solution, I mean, this makes it really nice. We have Q. So we found the best response function, but we're not actually explicitly asked for it. All we need is the Nash equilibrium price, quantity, and profit for each firm. Oh, and this one, so we wanted the profit for each firm. And what I did here is write out the profit for both firms simultaneously. The equation for the profit for the firm is Q, so little q, which is just 1/3. So here, we just plug in Q for each of these quantities, which gives us 1/2 A minus 1/2 times 2Q. So this is Q is equal to 1/2 A minus Q. And we have 2Q is equal to 1/2 A, which means Q is equal to 1/4 A. Okay. So then to find price, we take Q, which is equal to the sum of the quantities, which in this case we have 3 firms, each producing 1/4 times A, which gives us 3/4A. So we take this and we plug it into the inverse demand, which is A minus Q, which is 3/4A, which is 1/4 A. Okay, so that's nice. So we found Nash equilibrium price, quantity produced, and profit is our next task. Okay, so profit for the firm is quantity times price minus average cost. Average cost is 1. Quantity is 1/4 A. Price is 1/4 A. So just to expand this, we have 1/16A minus 1/4A. Something looks wrong here. So when we write this out, we end up getting 3/16A. So I'm just walking you through my thought process here. So we see a negative profit here, where up above we don't necessarily see a negative profit here. So what we need to do is just make sure that what we're seeing, because it looks somewhat out of place, we want to make sure that, so we perform sort of a sanity check to make sure that what we're seeing is actually true. So one way we can do this is with a graph. And on this graph, we want something related to profit. So what I propose here is we have average cost, AC, equals 1. We have marginal cost, which is also 1. Just the derivative. So it's also equal to marginal cost. And then we want some sort of, we want a marginal revenue curve, which is our best response. It's where we get our best response function from. So our marginal revenue is this. So what I'm going to do is just copy this down. Okay, so this isn't going to be 100% straightforward because what we're, at least so far, because what we're doing with the marginal revenue is actually, marginal revenue is a function of the other quantity choices. So one way we can get a handle on what's going on here is to plug in quantities in for the other two. So we know what they're producing. So let's just do this. We know what they're producing in equilibrium, which is 1/4 A. So I've taken both of them, and they're symmetric, so we can multiply by 2. So that comes out to be 1/2 A, and we have a whole 1A. So we have 1/2 A minus 2Q1. Okay, so when Q1 is 0, we have 1/2 A. When marginal revenue is 0, we have Q1 equals, so we set this equal to 0. We have 1/2 A is equal to marginal revenue equals 0. We have 2Q1, which means Q1 is equal to 1/4 A. So this is 1A over 4. And we know this is linear, so it looks something like this. Okay, so this is the point where average cost intersects the marginal revenue. For any quantities greater than this, profit is negative. Profit is negative. For any quantities less than this, profit is positive. So what we need to check here is where this point is. What's this quantity? So to do that, we just set our MR equal to 1. So if 1 is equal to 1/2 A minus 2Q1. So we have 2Q1 is equal to 1/2 A minus 1. Q1 is equal to 1/4 A minus 1/2. Or we can rewrite this as 1/2 A minus 1. Okay. So let's just, if we make sure this is, well, yeah, it will be positive. Be positive for any A greater than 2. Okay. So something still looks a little funny to me. Maybe the next thing we'll do is check this. Let's copy this down. Let's write this out correctly, or right side up. So we have Q P minus AC. Actually, we just want 1/3 A minus 1, 1/3 A plus minus 1/3. Okay, so we can pull 1/3 out. Write this as 1/3 times 1/3 times A minus 1 times A minus 1. So as long as A is greater than 1, then profit is positive. So looks like something happened between part B and D where profit became negative. And there are two possibilities. One is we messed up with the solutions here, our actual solving for the quantities. The other is our solution, just our arithmetic here. Something happened. Could have happened here too. So we're going to check these systematically. So the first place to start is at the beginning. It's a very good place to start, as they say. So let's start here. So let's just double check. So we have 1/2 times A, 1/2 times A. We have 1/2 times 2Q, which just becomes Q. So that's good. That's good. And this is good. Okay, so that looks fine. So for quantity, all we're doing is multiplying by 3. So quantity looks good. And price looks good. We have 1/4. Okay, so that's good. These are all good. So the problem is that price is below average cost. And how do we know that? Oh, I see what we did. This is squared. Okay. So that clears things up here. All right. So I think we're good here. So I'm gonna erase all of this. So hopefully, if you're still here, sometimes I find it helpful when I'm stuck on a problem to hear how others approach it. So I just ran into a problem in real life, in real time, where what I was seeing didn't sort of pass the sanity smell check. And so we approached it with different ways of trying to solve the problem by trying to understand the problem at a larger level. Okay, so that's what we did here. So this is the profit. And maybe this is actually the better expression. It's really just an aesthetic preference. So that's profit. And so here, as long as it's greater than 4, as long as A is greater than 4, profit is greater than 0 if A is greater than 4. Okay, so that's about it. All right, so I think we'll leave it here.